Welcome to Huawei eLearning Services. My name is Klaus Schweiger and today I will give an overview about the concept of SDN. After completion of this course, you will be able to describe the origin of software-defined networking SDN and the definition of SDN. Let's start with a look at the evolution in computer design. Traditional mainframe architecture are big block computers used primarily by large organizations for computationally intensive operations. They consist of a central, mostly very expensive but powerful hardware, a professional, often a proprietary operating system, and on top of that, many different professional applications. In this context, mainframe stands for an exclusive system with enclosing interfaces, a slow innovation speed, and typically small-scale industries. If you compare this with PCs, then you see that the architecture has strongly changed and is quite different from a mainframe. In general, it is much more modular. A PC provides open interfaces between its building blocks, between hardware containing the CPU and the operating system. You may have a PCI or a SATA interface. Between the OS and the applications, you may have an OpenGL, a DirectX interface, or any other interface. This architecture provides, as I already said, open interfaces. And from this aspect, you can derive several advantages. A rapid innovation speed for new services or applications, and of course, it can be used in giant industries. Let's remember the evolutionary step from a mainframe to a PC, and let's compare this with the evolution on the field of networking. Traditional networks are complex and quite difficult to manage. These networks have many different kinds of equipment, from routers and switches to firewalls, network address translators, intrusion detection systems, and so on. Obviously, these devices use different hardware platforms, and they also use distributed control plane software, which is typically closed and proprietary to finally provide complex professional features. The implemented hardware and software undergoes years of standardization and interoperability testing. Network administrators typically configure individual network devices using configuration interfaces that vary across vendors and vary even across different products from the same vendor. And although some network management tools offer a central point for configuring the network, these systems still operate at the level of individual protocols, mechanisms, and configuration interfaces. This central mode of operation has slowed down innovation pace, has increased complexity, and has inflated both CAPEX and OPEX for running such a network. In future networks, we will see a similar evolution as already happened on the field of computing. New systems will provide open interfaces in between the hardware and the control plane, and there will be also open interfaces in between the control plane and the applications. And again, this open interface architecture simplifies the integration of new applications, and so this evolution will speed up the pace of innovation. Let's now come to SDN, and first the definition of SDN. SDN stands for Software-Defined Networking. It describes this new network architecture, providing the before-mentioned open interface architecture. It was initially driven and developed by the Clean Slate program of Stanford University. The Clean Slate program was an interdisciplinary research program at Stanford University, which considered how the Internet could be redesigned with a clean slate. This means without the accumulated complexity of existing systems, but using the experience gained over the last decades. Software-defined networking now is changing the way of designing and managing networks. SDN has one major characteristic. With SDN, we separate the control plane. This is the entity which decides how to handle the traffic from the data plane. This is where traffic is forwarded according to decisions made by the control plane. So SDN requires some methods for the control plane to communicate with the data plane. One such mechanism is OpenFlow. OpenFlow is often misunderstood to be an equivalent for SDN, but it's not. Other mechanisms besides OpenFlow could also fit into the concept of SDN. So OpenFlow is just an important part of the SDN concept, but not exactly the same as SDN. Now, this separation of control plane and data plane allows a flexible control of network traffic. It allows higher innovation speed and an easier integration of future applications on this open platform. As we have heard, the higher innovation speed is a major advantage of the SDN architecture. So with SDN, it is possible to keep pace with the rapid development on the field of IT. With the separation of user plane and control plane, we may have a central control unit, which will be able to control various hardware devices. And with open interfaces in between hardware and software, we allow the accelerated integration of new applications onto the hardware. And with these major improvements and advantages, SDN will be the network architecture for the future. Finally, a few user opinions about SDN. The overall user experience is really great due to the open interface architecture. Operation, administration and maintenance experience shows improved efficiency. Another important experience is the faster innovation pace, which allows a much faster introduction of new services. So this course gave an introduction and an overview about the concept of SDN and into the origin of SDN. Thank you for watching.